Hello everyone. Today our goal is to graph quadratics from standard form and then to analyze those graphs after we've created them. Graphing from standard form is going to be in this. It's going to look like this. It's going to be f of x equals ax squared plus bx plus c. It's different than vertex form. Vertex form, as a reminder, was y equals a x minus h squared plus k. And vertex form was great for graphing because we could just look at the equation and say, hey, my vertex is going to be at h comma k. In standard form, we're going to have to do a little bit more work to figure out what our vertex is. So to find our vertex, we're going to have to remember negative b divided by 2a. Negative b divided by 2a. Once we know what a, b, and c are, we can plug them into that formula and we'll get a number. That is going to be the x coordinate of your vertex. So negative b over 2a tells you what the x value is. To figure out your y coordinate of your vertex, we're going to have to plug x in. So whenever we know what x is, we're going to replace x in our equation with that number and figure out what that equals, and that's going to be our y value. After we know our vertex, everything else is going to remain the same for our graphing. So our 1, 3, and 5 pattern is going to still be the same. We're going to take that and multiply it by whatever our a value is. The axis of symmetry is still going to go through the x value of the vertex, but now, since we had to do a formula to find it, it's always going to be whatever negative b over 2a is. The x-intercepts and the y-intercepts, both of these are going to be where your graph crosses the x-axis and y-axis. Both of these are still going to be written as points as x comma y. And then the last thing is the c value. Whatever your c value is, that's always going to match your y-intercept. So in your equation, that c value is that last number there. It's a constant. Your y-intercept will always be 0, comma, c. So let's take a look at this. Our first example here has f of x given to us. So our formula that we have to remember is x equals negative b over 2a. That's the one we have to remember to find our vertex. So in this equation, our a value is negative 2. And right away we can say, hey, since a is negative 2, my graph is going to open down. If it's negative, your graph is going to open downward and going to be like U-shaped but reflected over. My b value here is in front of the x term, so it's going to be negative 4. And my c value is the constant at the end without any x's, that's negative 2. So right away, actually, what we can do is we can plop down our y-intercept. It's going to be 0, comma, our c value of negative 2. And after we graph everything, if that doesn't line up, that's an indication that something maybe went wrong, either with finding our vertex or with finding our y-intercept. So let's see if we can make our graph cross our y-axis at 0, comma, negative 2. So let's go ahead and find our vertex. We're going to do negative b over 2a. So when I do negative b, I have negative 4. So I'm doing negative 4, or the opposite of negative 4, divided by 2 times a. And now my a value here is negative 2. So when I simplify negative 4, that becomes a positive 4. 2 times negative 2 becomes a negative 4. And 4 divided by negative 4 is negative 1. What this means is the x value of my vertex is negative 1. Also, my axis of symmetry should go through x equals negative 1. So this vertical line here, x equals negative 1, that's where my vertex is going to be, somewhere on that line. So let's go ahead and find the y value of the vertex. So what we need to do is we need to take and plug in negative 1 in for x. So we're going to do f of negative 1 to figure out the y value. So we have negative 2 times negative 1 squared minus 4 times negative 1, and then minus 2. So as we're looking at this, we need to simplify this. We're going to do the order of operations first, which means we're going to do negative 1 squared. And so when we do negative 1 squared, that becomes a positive 1. And then with the order of operations, I can do my multiplication. -2 times 1 becomes -2. -4 times -1 becomes a +4. And -2 plus 4 minus 2, all of that simplifies to 0. So my vertex is at -1, 0. And so I can put that point there. So now, if I want to graph the other points on my parabola, I need to remember that 1, 3, and 5 pattern. That's, again, all quadratics. Anything that has a highest degree of 2 is going to follow that 1, 3, and 5 pattern. But we need to multiply it by our a value. And now our a value in this case is -2. And so now when I multiply these, my new numbers become -2, -6, and -10. That means starting from my vertex, I'm going to go over 1, but I'm going to go down 2 on each side to get to the next point. From these points, I'm going to go over 1 and down 6 on each side to get to the next points. And then I will go over 1 and down 10, but it's off of my graph. So now I can connect those dots and make it into a parabola. I can see that my x-intercept is going to be -1, 0. It happens to be my vertex because my vertex is on the x-axis. My y-intercept checks out because 0, -2 is a point on my graph. My domain is going to be -infinity to +infinity. And my range, this one starts, again, we're going to go low to high for my range. This graph starts down for forever. So the lowest this graph gets is going to be -infinity because it's going to keep on getting lower. The highest this graph gets, though, is going to be my y value of my vertex, which is 0. And it actually touches 0, which is why we use the bracket. So let's go ahead and try to graph another one in standard form. So you'll notice this one here, again, doesn't have the h comma k because everything's all multiplied out. It's in the form ax squared plus bx plus c. And so b is 4 and c is 3. But in this case, a is 1 because there's an implied 1 in front of the x squared. Since a is 1, my graph is going to open up. I can find my vertex by doing the -b divided by 2a. So in this case, b was 4, so it becomes -4 over 2 times 1. So this is -4 over 2, or -2 for my x value of my vertex. And I can immediately write x equals -2 for my axis of symmetry. So to find my y value of my vertex, what I'm going to do is I'm going to take -2 and I'm going to plug it in, and I'm going to see what I get out. So I'm going to be doing -2 squared plus 4 times -2 plus 3. -2 squared becomes 4. 4 times -2 is -8, and then I have the plus 3 at the end. When I simplify all of this, that becomes -1. So my vertex is at the point -2, -1. To graph my other points, I'm going to use that 1, 3, and 5 pattern. Since my a value is 1, my stretch is not changing at all. So I'm going to go over 1 and up 1 from the vertex on both sides. From that point, I'm going to go over 1 and up 3. And from that point, I'm going to go over 1 and up 5. I can now create my parabola with my points. And I can see my x-intercepts are at -3, 0 and -1, 0 because that's where my graph crosses the x-axis. My y-intercept is going to be at 0, 3 because that's where my graph crosses the y-axis. And it lines up because my c value was 3. And those should always match in standard form. My domain is -infinity to +infinity. My range, how low to how high, my graph gets down to -1 and it goes up for forever, so that's going to be a +infinity. So for my transformations, you have to be very careful because it's not necessarily based off of the numbers in the equation. The transformations are looking at the graph. How is your graph move compared to y equals x squared, just your normal parent function? So looking at this graph, my vertex was at -2, -1. What that did is it moved my graph left 2, and it also moved my graph down 1. My stretch was just 1, so I didn't have an A value to talk about in my transformations because my normal stretch is just 1. And in fact, if we actually add something here, we could go ahead and write this in vertex form, either based off of the transformations of the graph, even though we were originally given this in standard. So for vertex form, my A value was 1. I moved left 2 and down 1. As a reminder, your H value is your left and right, and it always is the opposite of whatever your vertex is. So you are able to go from standard to vertex form to help you with your transformations or vice versa. So thank you very much for listening. At the end of this, you'll see a couple practice problems to make sure that graphing everything in standard form went well. Thanks.